Okay, so this is the Unit 3E handout, and so this one is going to focus a lot on total degrees in a polygon. Um, so in the first problem, you've got the same seven-sided shape on each diagram here, and two different students are trying to figure out how many total degrees are inside that shape. So, and it's got seven sides. It's called a heptagon. Hept is, I think, a Greek root for seven. Um, so what one of the students did was they started by picking a corner and then connecting that vertex to every other vertex that they could to make triangles. And when they did that, notice you couldn't connect it to the two that were right next to it. So you connect it to everything else, and when you're done, you end up with 1, 2, 3, 4, 5 triangles. So what they did was this student said, okay, well, 5 triangles, 5 times 180 is 900. This thing has 900 total degrees, right? Okay. The second student, instead of picking a corner, picking a vertex, picked a point in the middle, and then connected that to every vertex. And so this student, when they finished, said, well, I've got 1, 2, 3, 4, 5, 6, 7 triangles. So 7 times 180 is 1260 degrees. So the question is, well, one of these students is correct and one student is wrong. And so which one is it? So which one's right, which one's wrong? So let me point this out to you. If we look at what the angles of the triangles form, so here's one angle. Let me mark the 3 angles of every triangle, right? So in this one, we've got these 3 angles, then these 3 angles, and these 3 angles. And if you put all of the angles of the triangles together, notice what you form here is that angle, that whole angle, this whole angle, that whole angle, that whole angle, and this angle. So if I get rid of the actual triangles that I just drew in, the green stuff forms the angles of the polygon, the angles of the heptagon. So the 900 seems like that should be right. Now in this one, if I mark all the angles of the triangles, well, I've got this one and this one, this one and this one, these two, these two, these two, these two, and these two. But I also have all of these angles in the middle here, right? And now if I get rid of the red, notice I've got all the angles of the polygon. I've got these 7 angles going around the edges. But I also have an extra full rotation right there. And a full rotation is 360 degrees extra. So what you need to do, what this student needs to do, is get rid of the extra 360. And if he or she does that, then they have the 900 that they needed. Okay, so what I'll write down here below the first student, this method works. This method works fine. Whereas over here, this student was close, so this method almost works. But the student needs to subtract the extra 360 in the middle. Okay. Now notice over here, the number of triangles that we got, there were 5 triangles in here. Well, that's 2 less than the 7 sides that this thing has. If I had a 4-sided shape and I tried to use the same process of picking a corner and connecting it to everything, then I'm going to get 2 triangles. So 4 sides gives me 2 triangles, which is 2 times 180, is 360 degrees. If I had 5 sides, 1, 2, 3, 4, 5, and I pick a corner and I connect it to everything, then I've got 1, 2, 3 triangles. 3 triangles. 3 times 180 is 540 degrees. 6 sides, if I did 6 sides, and I connect to everything, 1, 2, 3, 1, 2, 3, 4, I get 4 triangles. So I got 4 times 180 degrees, which is going to be, what is that, 4 times 180? 720 degrees. And then we did, this was 6 sides. This was 7 sides. 5 triangles, 5 times 180 degrees. So notice, no matter how many sides I have, if I pick a corner and connect it to every other corner, then I'm going to get 2 fewer triangles than sides. So if it had 100 sides, I'd have 98 triangles, 98 times 100 degrees, 180 degrees. Over here, this one's a little bit easier. If I had like 1, 2, 3, 4, 5, 6, 7, 8, let's say 8 of them, and I start from the middle, well, every side, 1, 2, 3, 4, 5, 6, 7, 8, every side ends up being part of a triangle. So then you can just say, okay, well, it's however many sides I have, 8 times the triangles, each 180, and then get rid of that extra 360 in the middle, right? So you can do it that way too. I actually like this way better, this kind of method better, the second student's method, as long as you remember to subtract the extra 360, because it comes in handy later on in the school year. We'll be doing problems where it makes more sense to cut from the middle. Okay. Anyway, so that's number 1. Number 2 says, how do you find the total interior degrees for a polygon with 6 sides, which is called a hexagon? Well, we did it a little bit earlier. I'm going to do it both ways. So let me write here. Method 1. 1, 2, 3, 4, 5, 6. So method 1 was pick a corner, a vertex, connect it to as many other vertices as possible. So I can connect it to that one, this one, and this one. And remember, it's 6 sides. I get 4 triangles, right? 1, 2, 3, 4. 2 less than the sides. And that's going to lead to 4 times 180 degrees, which ends up being 720. In method 2, I got a hexagon, 4, 5, 6. Pick a point in the middle, and then connect that point to every corner, and form triangles. So in this case, I've got 6 sides, 6 triangles, with the extra 360 degrees in the middle. So then this one, the total interior degrees, would be equal to 6 triangles, that's 6 times 180, minus that extra 360 in the middle. And if you work that out, you'll also get 720 degrees, either way. Okay, so what about total interior degrees for a polygon with n sides? Alright, so if we did method 1, if it has n sides, right, in this case n was 6, up here we did several other ones, like this one's 7 sides, 5 triangles. If we had 100 sides, it'd be 9 triangles using method, if we had 100 sides, it'd be 98 triangles. So if it has n sides, and we cut it from a corner going out, we'll end up with n minus 2 triangles. And so then we would take that number of triangles and multiply it by 180 degrees. So total interior degrees would be n minus 2 times 180, just like that. So that's one way that you see it often written, and that's typical for textbooks, is to write it like this. We could also use method 2. So method 2 would be, well, you've got n sides, and if you cut it from the middle like we did up here, then every side ends up having a triangle associated with it, right? 6 sides, 6 triangles, 8 sides, 8 triangles, n sides, n triangles. But in every case, we'll get that extra 360 in the middle. So with an extra 360 degrees. So in this one, the total interior degrees of an n-gon, or n-sided polygon, would be the n times 180 per triangle. So I'll write it as 180 times n. And then we got to get rid of that extra 360. So here's another way of writing it. And if you think about this side, if I distribute that 180, I get 180n minus 360, which is the same thing as over here. Right? Okay, let's keep going. So a regular polygon has one that's both equiangular and equilateral, which really means it's like the perfect looking shape of however many sides it has. So like if it had 8 sides, it would look like a stop sign. If it had 4 sides, it would be a square. Right? So what's the measure of one interior angle of a regular triangle? Well, a regular triangle is equilateral and it's equiangular. So if all the angles are the same, then one angle of a regular triangle, well, if I take the total degrees and divide it by the number of angles I have, then I should get what one angle is. So the total degrees we already know is 180. So if I divide it by the number of angles, which is 3, I'll get 60 degrees per angle. Which, you know, I realize that's a little more complicated than you need to make it, but that's so that we can do the next part. So a regular decagon would be something with 10 sides. Now I'm not going to draw a decagon, so I'm just going to write here one angle of a regular decagon. Well, I need the total degrees of a decagon divided by the number of angles that a decagon has. Well, the total degrees in a decagon we can figure out using one of these formulas. So n would be 10 there. So it's, I don't know, we'll use this one. So it'd be 180 times 10 minus 360 divided by, and then the number of angles in a decagon, well, if it's got 10 sides, it's got 10 angles. So this is going to be 1800 minus 360, which is 1440, divided by 10. So each angle ends up being 144 degrees. This one says, what's one angle of a regular n-gon? So in this case, we don't really know how many sides it has. It has n sides, right? So, but it's the same formula. If we knew how many total degrees were in that thing, and we divided it by however many angles were in it, then we get what one angle is. Well, the total degrees is this formula, or if you prefer the n minus 2 times 180, you could use that. Either way, 180n minus 360. If I just divide that by n, well, then you have what one angle of a regular n-gon is going to be. Okay, and then the last problem here, I actually drew it 3 separate times. The last problem doesn't actually, depending on how you solve it, doesn't actually have to do with polygons. It's just more review of parallel line stuff. So, but this one talks about extending lines that already exist or creating something called auxiliary lines, which are helping lines. So you actually create a new line. So in this problem, extending lines is often helpful, and we've done it occasionally in the past. When you're doing helping lines, auxiliary lines, typically what you want to do is you want to draw lines that are already parallel to lines that are in the picture, or perpendicular to lines that are already in the picture, because right angles tend to be easy to work with. So let's try one where we extend the line. So I don't know. Let's try extending this line. So if we extend that all the way up, like that, right? Well, one of the things we could do is these two angles now form a straight angle. So this one on the inside is going to be 109 degrees, right? Because 180 minus 71 will be 109. Okay, so now I know that angle is 109. This angle right here, well, the nice thing is that I've got parallel lines that form this Z shape. And remember, a Z has alternate interior angles associated with it. And parallel lines give me alternate interior angles that are congruent. So that one ends up being 48 degrees too. Okay? And now I've got a triangle here, and the triangle adds up to 180, so I got 109 plus 48 plus x equals 180. And if you work this out a little bit, you'll end up with x being 23. So x is 23 degrees. Okay? So it turns out you could do this by extending this line downwards instead. And if you did that, then this one would be 109. And you could add these up to get 180, and this would end up being 23. And then you could use a big Z shape right here where the top and bottom are parallel. So if that's 23, this alternate interior angle is 23. But let me show you another one. So that's an extending lines one. Let's try drawing a parallel line. So notice I've got two parallel lines. If I end up drawing one right through here, right there, a third parallel line, it doesn't necessarily cut the 71 in half. There's no reason that we know that it would cut it in half. And in fact, it doesn't. But one thing you could do is say, well, look right here. There's a Z shape with the top and bottom parallel. So this one's 48, this one's 48. So if I do 71 minus 48, I'll get 23 right here. And then if I create another Z, or backward Z, I guess, right there, well, top and bottom are parallel, and if this one's 23, then that one's got to be 23. So there's another way of doing it. So I'll show you one other one. All right. So in this one, I'm going to draw a perpendicular line. So I'm going to make a right angle. I'm going to do it straight down here, right through that point. Right angle, right angle. So in this case, well, that's 48, that's 90. If you added this triangle up to get 180, then this is going to end up being 42 degrees right here. And then we've got that these three angles add up to 180. So if I did, I'll call this y for now. So if I do 42 plus 71 plus y equals 180, then I'll get, I don't know, what is that? 113 plus y equals 180. So y ends up being 67. So now I know y is 67 degrees. And now I've got a triangle up here. So I can do 67 plus 90 plus x equals 180. And if I work that out, I'm going to get x is 23. 23 degrees. So there we go. 3 different ways, all pretty different from each other, but all of them result with x equals 23. All right, I hope that helps a little bit, and I'll see you in class.